OER, UDL, and math, using open educational resources and universal design for learning to facilitate conceptual mathematical learning for adults. I'm Sue Jones. I support underprepared learners at Parkland College, a community college in Champaign, Illinois, about 5 miles west of the University of Illinois. This is where the Center for Academic Success once was on a typical winter day. OER and me, I've always had the privilege to be a sharing is caring person. In 2013, I participated in the OER STEM project, facilitated by the American Institutes for Research. For 2 years, we collaborated on curating and creating OER for adult ed and community colleges in math and science. We developed professional development materials for adult ed instructors, and OER Commons added an adult education category in its grade levels. In 2017, I participated in Power in Numbers, Advancing Math for Adult Learners, sponsored by Luminary Labs. We tested, evaluated, and posted reviews of OER and OER curricula to create a self-sustaining community of content sharing and curation. Well, both projects communicated through the government-sponsored Links site, and the community has been eliminated by our current president's administration. We need to build other options. Current trends are to place all students in college-level math and eliminate remedial math because somehow those courses are the inequity, not the students' previous experiences and opportunities. Even in the Power in Numbers project, we were supposed to focus on advanced math. Recent developmental ed reform laws serve the students they wish we had, or perhaps the students they prefer to serve, dismissing the inequities in K-12 that bring students to us who have been denied the chance to develop mathematical thinking skills. Zaretta Hammonds describes cognitive redlining as the way we underdevelop the cognitive capacities and information processing skills of diverse students. Basically, it's accepting that certain students really can't understand things. It includes teaching above their processing so that the advanced learners continue to advance, reinforcing the notion that the rest of them should just try to pass the class. I've had a lot of experience with these learners, and if we start where they are, they can build those street thinking skills. Don't they just need a little review? Short answer, no. If they're asked to add 1/3 to 0.5, or figure out the diameter of a circle given the circumference, they'll apply a procedure, do something that looks right, but isn't. So they'll find the radius and stop. Interviews confirmed that they think math is a lot of mysterious symbol manipulation procedures that only certain people are good at. Bring on UDL, Universal Design for Learning. Universal Design for Learning is a set of guidelines for designing inclusive, accessible learning experiences from the CAST community. Those folks are experts at assistive technology and a lot of other things. UDL 3.0 aims to address biases and systems of exclusion beyond the more familiar physical or technological barriers. These are extremely applicable to the challenges presented by adults who need to develop mathematical skills and thinking. You can get many versions and translations of the guidelines at the CAST and org site. It's always a work in progress, like OER. For instance, until recently, engagement was third on the list. They bumped it to first. It helps us address those systemic barriers, the inequities, the I can't do math issues. I get stories first, they're not alone, and then we teach and inspire persistence and self-regulation. So this would vary from place to place, but I've got a survey that asks, do they think they're in the right class? Is their assessment score accurate? And then some Likert-style questions about math being hard to understand, knowing which parts you don't understand, if you know your times tables, and I'll have this and links to other things at the end. It's also important to figure out what students actually need to bring into college math and college courses. And again, it's more about the mathematical thinking than the procedures. So I build in explicit teaching of the thought process they can carry over into higher levels. For lots of folks, they don't need the higher levels, but how proportional reasoning works with place value means that fractions, decimals, and percents aren't completely different arbitrary routines, and it opens the doors to higher levels of math. I have lost count of how many times I'm told, why didn't they teach us this? Or why don't they teach us this way? That's why I'm here today. I do include a little bit of math. Most folks get number 1 dead wrong. Lots of folks show work for number 3. My construction career folks tend to get this one right because they think spatially. Now that's only the beginning. Sustaining the effort and persistence. It's a lot easier if we build some trust from the beginning, but it needs to be structured for success. This is the thing that the Dev Ed reform folks can get right. We need to shift the classes from being a competitive atmosphere where you're always required to prove yourself, instead of being a community of people learning and growing together. That's important at all levels. We need explicit instructions. Do things in class first. We don't even know what they don't know. Lots of low-stakes assessment designed for success, and then be sure they own their progress. The second category is presentation, our actual instructional materials. This second one, language and symbols, is where so much cognitive redlining happens. What is divisibility? What is an integer? Fractions, equal signs, parentheses. Those little dashes that might be subtraction, might be negative. It's worth taking the time to build that understanding. We can be concrete and visual and create it with open source tools. And it doesn't mean they have to know 5 different ways of expressing it. Did somebody say fractions? This is an example of a lesson that went over astoundingly well with our apprenticeship prep learners. I start telling them we're going to build a deep understanding of fractions, and that one reason they're hard for folks to master is we have to work with 3 ideas. But I'm going to teach them differently than grade school because their minds are more mature. So many fraction lessons begin with pictures like this, but it's not deeply connected to the language or the idea that we have to have the whole thing is 8/8 in our minds to really make sense of it. I also note a big part of math is being sure you are answering the question they ask. This is one of those processes. Are they asking what pizza is there or what pizza was eaten? They don't get this for a while, but we keep building what the whole thing is. So when they ask what pizza was not eaten, they'll count it. But we're going to learn that 8/8 minus 3/8 is another way of getting there. I emphasize the denominator is like the units. So this is like saying 8 inches minus 3 inches leaves us 5 inches. Then we do it again. We might go faster. This is a new framework, a new understanding. Then we do it some more. As fast as you can, as slowly as you must. It ends up saving time down the road because they really know 12/12 is the whole cake. Did I say language? Fast forward, I use lots of pictures and examples. Then we translate it into symbols. And then we get to the next amazing process in math, substitution. The first part of answering a math question is often, what? Then you look again and see, is there anything that has a simpler way of writing it that really means the same thing? So 0/12 plus 3/3 plus 5/1 is really saying 0 plus 1 plus 5. And this can all be done with open source tools and shared out. I have a similar routine for learning how to solve algebraic equations. It's another low floor, high ceiling lesson. And then divisibility rules, we can give them a visual anchor. Oh, and exponents. For almost everybody, we focus on squares and cubes. The visuals really help with understanding. And I've got manipulatives too, but they get the chance to explore powers of 1 and 0. And finally, conceptual front-loading. When Alex asks them this question, I can say, stop, let's do this first. And if they've experienced my fraction introduction, this goes really fast. 4/4 minus 1/4 is 3/4. Oh, yes, I've got a special lesson in how to add fractions with different denominators too. The third category, action and expression, that's doing the math and the assessment. Moodle is amazing. There's incredible potential here. It will let me set up a question with 2 possible combinations. So if they swap out the 4 and 5, it's right, but it has to be a combination of 4 and 5. And yes, I can include visuals, and I've gotten incredible support from the community too. Yes, a lot of things that the Pearson products can do can be done with Moodle. Drag and drop. I had lots of help with this one. My helper took my question and made this beautiful puzzle to drag and drop things to. We both had fun. GeoGebra, another great open source resource. How often are learners taught the rules for divisibility when they don't really have any idea what it means? Learners can explore positives and negatives. It's open source. I can open up this exercise and have a working copy to adapt. Yes, there's a learning curve and a little overwhelm factor, but collaborating really helps with that. There are zillions of other answers. And print or HTML can be made more cognitively accessible. Bigger fonts, uses similar models in different mathematical contexts, lots of number lines, sort different ways of looking at the same idea, and share. My video on number lines in PowerPoint is my most popular video. There's so much potential. Let's do this. Thank you for listening to my lightning talk.